remember. Wow. Okay, I see. The homework, creating a math with different rules is one of the most interesting problems of math, because it's really hard to imagine math with different rules. The homework puzzle input consists of a series of expressions that consist of addition, multiplication, and parentheses. Just like normal math, parentheses indicates that the expression inside must be evaluated before it can be used by the surrounding expression. So it's eager evaluation. Addition, you will find the sum of the numbers on both sides of the operator. Multiplication, you will find the sum of the product. However, the rules of operator precedence have changed. Rather than evaluating multiplication before addition, the operator has the same precedence, and I evaluated left to right regardless of the order in which they appear. So, can we finally use parser with precedence for this task? For example, the steps to evaluate the expression are as follows. 1 plus 2, first, then 3 multiplied by 2 with left precedence. Parentheses can override this order. For example, here is what happens with parentheses are added to the... Makes sense. Here are 3 more examples. Before you can help with the homework, you need to understand the detail. Calculate the expression on this line of the homework. What is the sum of resulting values? Easy. Actually, I would need to learn how to parse using precedence. Parse each symbol, but then we are saying step in place or something, and it will erase the precedence, and what it will do, I don't actually know what it will do. So what we can do is just to define recursive parser. But I'm sure why do you need precedence there? Let's read documentation. Checks whether the precedence context is less than or equal to n, and if not fails, if so, parses p in the context n. Okay. Step: increases the precedent constant by 1. Reset the precedent context as well. So I'm not sure. It seems to me like precedent parsing is just tries to input the int as a context, and you are manipulating this context. So I'm not sure how much it would make sense here. Oh, I see. Maybe it's important because we have a recursion, so we need to remember at which parenthesis we are currently on. And in this way, you will know. don't know why can't we just use precedence recursively? What's the problem with that? What we probably need to do is to just say read number, then skip spaces, then read operator, or read parentheses. So, and if read parentheses, then read expression. How do we know when expression ends? The expression itself should know. And when it ends, we skip spaces and read the closing parentheses. So, question here, can we have ambiguity here? I believe we cannot, because we non-ambiguously know that the first encountered closing parenthesis is ours, because all inside should have been parsed with child parser. But now I understand why you need precedence. So probably what you need it for is, for example, you have more complex structure and you can use, for example, let's give an example of string. And inside of string you can also have quotes. So what you can define is that if the precedence is more than 2, then quotes that I am encountering will be counted as the end of the string, not as the beginner. Doesn't make sense. Okay, maybe it's a bit different. So probably I'm not really sure why we use precedence. One more question. In the input, do we have a single number, or rather parentheses as an outer operation? I don't see them, but let's create generalized, because it's nice stuff to have. So what I mean is that we can define a function read expression. They actually have a type. Will have a type expression. And expression can be number, operator, or parentheses. And yeah, Brackets. No, brackets is different. We have a small word for brackets. Okay, so expression. Expression can be first, skip spaces. First things first. Then it can be either a number or parentheses. Let's see. So number is our case is munch is digit. Head R3 file not strong. Expect that your file paths actual type string. Yeah, because head R3. Yeah, my bad. Yes, we can. What also we have this choice. Yeah, let's use that one. Just munch. What we need here is also read and also number. Read and number expression. Yes.
Yeah.
we just need to read break. So we using parentheses on read precedent, and it will parse another expression because it's expression here, and that should be it. Par expression. Yeah, but we not only want to have parentheses, just parse expression. We want to have here a character, right? We expect here to have parentheses, then skip space, and then expression. That's just fine. Use do. And if we're using do, we can also use an operator. Yeah. Okay. Pretty much type in and we press it. First time we go to read precedent. Oh, first is precedent, then in. I see. No worries. It's fine. Let's try to read some stuff. So we are trying to 2, right? Yeah, not much we can read actually here. Number 2. And parentheses. No parse. That's interesting. Aren't we using skip spaces? Oh, we are using it only once, right? We are saying skip spaces. Oh, also we never expect to have closing parentheses. Which is definitely bad. Yes, that's right. We actually need here closing character. but also, yes. Should we have skip spaces after an expression? I don't think we should. And so I will do skip spaces here. Okay, so now no parse. Okay, what we also haven't done is that after so read number, that's number expression, and that's fair. What's not fair is, yeah, after the parentheses we shouldn't read spaces, because for every our expression we will have skip spaces. Okay, only natural to do. So question is, why there is no parse? Let's say we start with for just parentheses 2. That works. What if we put space here? Works. What if put works? Oh, I see. So the okay, so maybe I put a different number. I don't understand yet. What was wrong? I just don't understand. Yeah, okay, it's parsing. Okay. Yeah, I'm not sure what was wrong. Hard. Why I'm saying it's hard? Because we need, after parsing a number, we need to decide, is it just a number or is it an operation? So that's what hard is, having number as an expression. How would you do it? So in proper compilers you would have reading lexicons, I believe, and then you're converting them to the expression. separation by, I believe, has an ambiguous parser. So here we don't say num expression. But we cannot say just expression. Okay, so we need num expression. No, but we don't need say instead of num expression, just expression. What we need is to num expression separated by. And what we'll receive is the number of okay, it will delete separators, which is not suitable for us. So what would we need here is probably num expression or num expression plus something, and we want the num expression plus something to be better. So maybe that's why we need precedence. Maybe here we can actually say, okay, through all choices that we have, please pick the one where we get maximum amount of operators. Maybe that's the reason why we can do it. Let's try it out. So pair plus plus, we need the operator expression. Which will be still number, num expression, but then you will have skip spaces. Then we need to read character, and we need to say that it should be this one. Yeah, so that's be satisfied, be much. No, we need to read one character, and we need to fail in case if it's not satisfiable. So what we'll do here is skip spaces, that's true. And then we say picture, yeah, so operator. But also we say when operator not in. So we check in by using element, and I believe there is a function not element plus or multiplication. Then we say list, if yes, and otherwise we are saying otherwise, yeah, let's operate one. That's operator, and let's operate two. Run. Num expression. Also we need num expression doesn't need spaces, so we need to skip returning operation operand operand 1 and operand 2. So plus operator expression. Let's see how it works. Alright, because each character has a specific character that you want to read. I see. Oh, satisfy is also let's actually what we need. Satisfy why not parts? That's interesting. It's not ambiguous, it's just not parts. Oh, because I say please read the num expression, but what actually I want to say read expression. So what's wrong with that? So when we read in operand 1, we also need to read expression. Do you see the problem? The problem? Actually, I don't see the... I see the problem, because if you will try to read expression, you will stuck in the infinite. So you need to read something. Okay, then we say that parenthesis is actually the first we are trying to read. Just to not get in the loop. So we are saying either parenthesis, if no parenthesis, it must be number. Yeah, it sounds reasonable. But the second part, it can be different. So here we don't have num expression, we will have read bracket. must be an expression. Yeah, right. Wow, it's happened. It actually worked. And it's not ambiguous, which was my main concern. What else we should try is to... And now if parentheses, then it's just... no, I won't read it. Why? How adding new character can say no parse? That's ridiculous. I don't see why. I see. Because read automatically appends skip spaces. Or something like that. So any character, it doesn't matter if it's star. What matters here is it's not space. I see. So we actually need to be strictly specific to satisfy read. We actually need to parse everything, and because parentheses won't parse it. Yeah, because when we say with parentheses, we say okay, in return expression, and that will be everything, just parentheses expression. What we actually, and that's the same with number expression, right? So operator expressions. But operators also have the first operand are the parentheses. Okay, to read the expression. So probably what we want to do is to have not having it operators inside, but we can have operators inside. That's why it becomes ambiguous. That's why it becomes possible to do. How we can do that? Then it's an interesting question. Okay, I see. So what we will do is say that if we're saying just with parentheses or we are saying just with numbers, it should be end of file. If it's not end of file, you must use over. That's how we do it. So we still use so we will say it's either parentheses or it's a number. Both are fine, but after any of them I expect to have end of line. If you don't have end of line, that's all. End of file, yes. So my only question here is what operator p+++ has 5. So 1 is lower, which is just fine. So I can use here and p end of file. And by doing this, I'm saying, if you are reading expression and you parse expression or number, and then that's all, congrats. But if you don't have end of file, please. Oh yeah, we need also skip spaces for saying that, because you have to keep spaces up. What's wrong with this is that we won't be able to read sub-expressions. Wow. Because sub-expressions doesn't have end of a file after them. What they have, sub-expressions either have closing parentheses. No, we need. Okay, so we require. Yes, because it can be called recursively, right? So when we read in sub expression, we will use this option, which will decide. It will never decide to read parentheses or numbers, because it expects this to be end of file, which is not. Because we should parse everything until closing parenthesis. What's wrong with this approach is that we should choose the correct precedence, right? Because if we have two open brackets, parentheses, then we need to stop parsing current expression only over the second parenthesis. Hard. So one option that I'm considering is to read everything to the next parenthesis. How can we do this? Of course, we can use something like loop to get the thing, which will loop the string without consuming. Doesn't sound great to me.
I won't give up the fight.
Not challenging.
You're waking up my animal side.
So what do you want to happen? For each expression you want to say
I cross the line, my
or read
enemy's
and
through. I'm not afraid, 'cause I'm falling into.
so our question is that we need somehow to read operator if we can. But if we cannot, we use parentheses or non-expression. The problem with this approach is that when I try to read operator, I will need to read expression as the first operand. And what's the problem with that? Is that when I try to recursively read an expression, I also will try to read operand, and which is also expression. I will try again. So I actually need to read something. Otherwise, I will go to infinite recursion. I cannot Okay. So further from home in here we did during either parentheses or number expression. And that will be our first operand. And then we will try to parse an operator, which will be this. And it will give us operation and the second operand. Wow, wow, we did this. Amazing. So we just left out with calculating the stuff. Just calculating the stuff is even easier. Actually, now that I think we don't need to parse, but doesn't matter. We just say evaluate, right? Eval expression.
Embracing the night sky,
And we have number
hunting
x
down the
is
one
just
who
x.
hurt my love, erasing a
Also we have
lifetime.
operator plus.
I walk alone, I'm a lone wolf, watching it unfold, observing it. I'm
Eval
just an
operand 1
outsider
plus
looking
eval
in.
operand
How did it
And we
ever
also
become
have,
so real? I'm just a hunter and you're the kill.
and we have
Sleep of the night, sleepwalking. Now I can sense you're near.
we just
Coming my way, sleepwalking. I feel both love and fear. Night after night, sleepwalking. Now you can sense I'm here. Leading your way, sleepwalking. I live for
okay, so
blood
here
and
we only
tears.
should say print
You're searching for
eval
someone
read expression.
who is gone
So
and I can change it now.
yeah, we eval takes specific type, so
We are damned
yeah, our
and I can
examples.
change it now. I can remember, I don't forgive. I'm just an outsider looking in. Say
Example
till
1.
encounter won't let you win. I'm just a hunter and you're the kill. Slave of the night, sleepwalking. Now I can sense you're near. Coming my way, sleepwalking. I feel both love and fear. Night after night, sleepwalking. Now you can sense I'm here.
Okay, so we
Leading
have
your way, sleepwalking. I live for blood and
example
tears.
1. Yeah, 95. Wait, it should be 75. What happened, guys? Let's how many? Yeah, I just copied the expression, so it should be 1 plus 2, 3, 3. So we parsing is left percent, and we need to parse is right precedence, right? Let's do it without
Now I can sense you're near. Coming my way, sleepwalking. I feel both love and fear. Night after night,
Operation plus.
sleepwalking.
Oh, right, so the operation plus will be the last one.
Leading your way, sleepwalking. I live for blood and fear.
Oh wait, but I'm reading here parentheses or numbers version. I just need to recombine. Okay, so what we can do is to write additional function which recombines everything to be not left to right tree but right to left tree. So I will explain. So we have eval, but the other function we want to use make right parse it just like that. So what we can do is to say that expression have everything is a great idea. I think it's just simpler to make right precedents. Precedents? Yes. And what we say is if it's an rebalancing is needed only when we have two operators. We know that we will read in the left operand, we will have either number or parenthesis. We will not have operator. Or we will have parenthesis and inside operator, but not outside. So we know for sure there is no operator here. And we will need to rebalance only when we have operator here. No. Yes, yes. So if we have operator 2, so one operator 2, we will have second operand, operand 2, operand 3. Our allowance should consist of since every operation should be actually we can do just by reversing everything, but it's not possible. So what we will do is we will have operator 1 operand 1 and operand 2 and bigger operator 2 on operator 3. Yeah, so we basically like having different parentheses because we have right precedents. Oh, we actually have left precedents. Ha! Yeah, yeah. Yeah, make left precedents. Does it work? Yes. So when we elevate let's say make left precedents. How would it look? So it's 1 plus yeah. We need to call recursively on the third operand, I think. No, on the same operand. We'll need to implement. Yeah, that's it. Make left precedent anything except John Max. Yeah, if we cannot do this, we cannot do this. But that's strange. Why is it not exhaustive? X should be exhaustive. Ah, yeah, that's right. Yeah, 1 plus 2. Now it works.
Silence.
So how about 71? 5 in. Example 6 in. Okay, so let's start with example 4. Which is incorrect.